Hi data scientists, welcome to Breath of Data Science. I'm Tarun. I have a master's in data science and I'm currently working as a data scientist in Germany. I created this channel to share my knowledge of data science, programming and the related things. This is part 2 of 2-part video. In the first part I covered what is aggregation, what are the purposes of aggregation, what is sampling, what are the different types of samplings, what is dimensionality reduction, what is its purpose, and what are the techniques that you can use to do dimensionality reduction. And I started with feature subset selection, and I'll continue with that here, talking about the different approaches for feature subset selection and how can you do feature creation, the general methodologies, and then how you can perform discretization and binarization of categorical values. And finally, I'll conclude the video with variable transformation. In case if you haven't checked out the part 1 of the video, I'll highly recommend that you check out part 1 to understand this part better. So while some irrelevant and redundant attributes can be eliminated quite easily and immediately by using some common sense or domain knowledge for that particular problem, selecting the best subset of features generally requires a systematic approach. The ideal approach to feature selection is to try all possible sets of or subsets of features as input to the data mining algorithm and then take the subset that produces the best results. So there are 3 standard approaches that you can employ to do feature selection in your own problem solving. The first one is called embedded approaches. So in this approach, feature selection occurs naturally as part of the data mining algorithm. So what it means is, when the data mining algorithm is executing, the algorithm itself decides which attributes to use and which to ignore. The second approach is called filter approach. In this, features are selected before the actual algorithm is executed using some approach that is independent of the data mining task. So for example, we might select sets of attributes whose pairwise correlation is low as possible. If you don't know what correlation is, I explained it in the last video. I'll tag that in the description and you can check it out top right of your screen now. And the third approach is called wrapper approaches. So these are methods use the target data mining algorithm as a black box to find the best subset of attributes. So here you see on the screen a flowchart of a feature subset selection process, wherein you have the attributes in the beginning, then you define a search strategy, then you identify a subset of attributes, then you evaluate the subset of attributes on whatever metric or criteria you define, and then you say, okay, does it reach the stopping criteria, or whether you have the performance that you desire, and if yes, then you select those attributes and move to the validation process. If it's not up to the desired metric or desired measure, then you repeat the process from the search strategy again. So now moving on to another procedure or another type of data pre-processing that you can do, which is feature creation. This involves creation of new attributes that can capture the important information in a data set much more efficiently than the original attributes could. What it means is, let's say you have 5 attributes in your data set right now, but you think a combination of them provide you with a better attribute. For example, let's say you are talking about keywords, products ranking based on those keywords, and then you have 2 attributes available with you. One is the search volume and the rank of the product for that particular keyword. So you can combine the search volume and the rank of the product in the keywords and create a score out of it, and then use that score to identify which products are better. So there are 3 general methods where you can use feature creation. The first one is feature extraction. So in this method, the creation of a new set of features from the original data is done, and it is called feature extraction. So let's consider a set of photographs where each photograph is to be classified according to the condition whether it contains a human face or not. The raw data is a set of pixels, and as such, it is much not suitable for many types of classification algorithms. However, if the data is processed to provide higher level features such as presence or absence of certain types of edges and areas that are highly associated or correlated with the presence of human faces, then a much broader set of classification techniques can be applied to this problem. But remember, this feature extraction method is highly domain specific and problem dependent. The second method is feature construction. So as I explained in the example for keywords, their search volume and their ranking. So sometimes the feature in the original data set have the necessary information, but it is not suitable entirely. So in this situation, what you do is you create a new feature, as we did in the example. We created a score out of search volume and rank to get a new feature which is much more useful than the original features. Another example is if you have mass and volume, then rather than using them individually, you can create density out of mass and volume and then use density as your attribute. The third method for feature creation is mapping the data to a new data space. A totally different view of the data can reveal quite a lot of important and interesting features. So for example, consider time series data, which often contains periodic or seasonal patterns. So if there is only one single periodic pattern and not much noise, then the pattern can be easily detected. But if on the other hand there are a number of periodic or seasonal patterns and a significant amount of noise present in the data, then these patterns are very hard to detect. Such patterns can nonetheless be detected by applying a Fourier transform to the time series in order to change to a representation in which frequency information is explicit. Now let's talk about the second last way of data preprocessing, which is discretizing and binarizing your data. So first, let's say what is discretization. Discretization is the process of converting a continuous attribute into an ordinal attribute, and a potentially infinite number of values are mapped into a small number of categories. And discretization is commonly used in classification, and a lot of classification algorithms work best if both the independent and dependent variables only have a few values. So in case you are not sure about what continuous and ordinal attributes are, I created a video on that as well. I'll link that in the description box and you can see it on the right of your screen now. And as far as for independent and dependent variable goes, so the dependent variable is the variable which you are trying to predict or calculate using data science or machine learning algorithm, and the rest of the attributes are called independent attributes. So what is binarization? Binarization maps a continuous or categorical attribute into one or more binary variables. And this is typically used for association analysis. I'll discuss what association analysis in a future video. And binarization is often used to convert a continuous attribute to a categorical attribute and then convert a categorical attribute to a set of binary attributes. And this is used in association analysis most of the times because association analysis needs asymmetric binary attributes. So for example, eye color and height are measured as low, medium and high. Let's see an example of conversion of categorical attribute to 3 binary attributes. So you see the image on the screen. You have 5 categorical values: awful, poor, okay, good, treat. Then you assign an integer to them, and then since it's 0 to 4, you can represent it in 3 binary bits. So you convert it into binary. Now let's see the conversion of categorical attribute into 5 asymmetric binary attributes. So we have the same categorical values, we have the same integer values assigned to them, but rather than now just converting them to binary vectors, we have a vector of size 5, and each bit represents one categorical value in itself. So if you see x1 is 1, then it means the value of that attribute is awful. If x2 is 1, then it's poor. If x3 is 1, then okay. If x4 is 1, then good. And if x5 is 1, then great. So now let's see the final step or final type of data preprocessing, which is variable transformation. In variable transformation, an attribute transform is done, which is nothing but a function that maps the entire set of values of a given attribute to a new replaced values. Such that each old value can be identified with one of the new values. So for example, there are a few simple functions to do that. So if you convert a continuous attribute to, let's say, log of that attribute, then you have transformed that variable. Another example is, let's say you have negative numbers and positive numbers in one particular attribute, but algorithm that you're working on requires positive valued attributes. So you can use a square of that attribute, which is nothing but transforming the attribute with the power. Then you can use an absolute method as well, where you convert the value into absolute of that particular value, or you can just use exponential power. So these are a few examples. The other way you can transform a variable is to do normalization. So normalization is a technique where you adjust the differences among attributes in terms of frequency of occurrence, mean, variance and its range. And then there is something called standardization. In statistics, it refers to subtracting off the means from that particular value and dividing by its standard deviation. You can see the formulas for normalization and standardization on your screen right now. In the next video, I will showcase how to do it in Python and with an actual data set. So I will see you again next time. If you liked the video, then don't forget to subscribe, like and comment to support me in creating more videos like this. I will see you again next week.